Hello everyone, welcome to RN tutorials on mechanics of fluids. In this video lecture I would like to discuss about differential manometers, and these are used for finding the difference between the two pressures. So before that I would like to give a small statement related to the differential YouTube manometer. So that statement we can give as a differential YouTube manometer is a device used to find the difference of two pressures at two different points. That means differential YouTube manometers are used to find the difference of two pressures at two different points in two pipes in which they are flowing. So that means ultimately we will find out the difference between the two pressures at two different points here in a flow field. And at the same time here there are mainly two types of differential YouTube manometers. That means again we are having different types of the differential YouTube manometers, so under which we are having mainly two types. And first one is simple differential YouTube manometer, and second one is inverted differential YouTube manometer. Okay, so here based upon the pressure amount of the pressure measurement, we can use either simple differential YouTube manometer or inverted YouTube differential manometers. The simple differential YouTube manometers are used to find the large pressure differences, and whereas inverted differential YouTube manometers are used to find the small pressures differences. Okay, so based upon the high and low pressure values for which we need to find out the difference, in that case we can use either simple differential YouTube or inverted differential YouTube manometer. Okay, so in this video first I would like to explain about the simple differential YouTube manometer only. So let us have a view. So simple differential YouTube manometer, which is also in the form of YouTube only, with two openings and with one heavy liquid inside it is provided. So here every time we assume it as a mercury. This is the heavy liquid, and initially the liquid will be at the same level, and these two openings are connected to the two different pipes at two different points where we need to find out the pressure difference here. So the arrangement will be like this. These are the two pipes, assume. Okay, now two pipes for which we need to find out the pressure difference of these two pipes, and assume as points A and B. So at A and B the pressure will be acting at A as PA and at B as PB, we are assuming here. So the difference between PA and PB we can find out with the help of this simple differential YouTube manometer here. So whenever we connect this differential YouTube manometer to the two different pipes at two different points, automatically the water tries to, or liquid, that means liquids try to enter into the two limbs of the YouTube manometer. Here assume this is one different liquid, this is one different liquid, both are lighter than the mercury here. So two different types of the liquids are flowing through two pipes which are lighter than the heavy liquid here we are assuming. So when we connect, automatically the liquids try to enter into the left and right limbs. So when they enter, according to the pressure variation taking place, that is in the pipe A the pressure may be larger than the pipe B. So here again I am assuming the pressure which is acting in the pipe A is more than the pressure acting in the pipe B. So according to that, the fall of the heavy liquid takes place in the left limb, and the rise of the heavy liquid takes place in the right limb. So similarly the water enters into it, and here the fall has been taken place. Similarly here the rise takes place, and automatically amount of the liquid from the B pipe also enters into the right limb. Okay, here based upon the larger pressure in the pipe A, there is a rise in the heavy liquid, rise of heavy liquid in the right limb has been taken place. Okay, so after assembling the manometer to the two pipes, this kind of the arrangement we can see, and based upon the levels we got, try to assume a datum line. Okay, with respect to datum line we try to assume the heights. So assume the height of the liquid in the left limb as h1, and the height of the liquid in the right limb from the level of the mercury as H2, and again the height of the mercury, that is the heavy liquid, from the datum line as Hg. Okay, so by assuming this, we can find out the pressure difference between PA and PB. And again here we are assuming two different liquids. So based upon the two different liquids, the two liquids again have two different densities, so that's why we can assume them as ρ1 and ρ2. And similarly the mercury also heavier liquid than these two, so automatically it will be also having different density, that we assume as ρg. So while deriving an equation, we can consider that. So again already we know whenever we use the manometer, whenever we connect it to the pipe, so according to the pressure variation taking place, certain constant level takes place in the manometer. So similarly here also we got constant level for the mercury. So this constant level is obtained whenever pressure reaches the equilibrium condition on both sides, that is in left limb and right limb. Okay, so again we can apply the equilibrium condition here. So that is total pressure in left limb is equal to, we can write it as total pressure in right limb. So first we try to write the total pressure acting in the left limb. So already we know certain amount of the pressure is acting in the pipe, that is PA. Okay, write it as PA. And in the left limb, according to the height of the liquid, we can write the pressure which is acting inside the left limb only. Okay, so according to the H1 from the hydrostatic law, we can write PA plus for the liquid which is in the left limb, the pressure can be written as ρ1 G H1, we can write it as, which is again from hydrostatic law only, and that is equal to, see here only two pressures, one is that is the pressure already acting in a pipe, and another one is liquid present in the left limb. Okay, and the sum of these two can be equal to the pressure acting in the right limb. So equal to pressure acting in the right limb, we can write it as, again first we try to consider liquid from the pipe B. So liquid from the pipe B. So already here pressure acting PB in the pipe B. So we can write it as PB plus, we can write it as again the whatever the liquid present in the right limb, that is the second liquid which is from the pipe B only. So related to the height H2 for the liquid from the pipe B, we can write it as, again from the hydrostatic law, ρ2 G H2, we can write it as. Okay, and again one more pressure is there in the right limb, which is due to the heavy liquid has raised in the right limb. So that is again plus, we can write it as ρ G G into Hg. We can write it as ρ G G Hg. Here ρ G and Hg I am giving the suffix as G for the heavy liquid. Here the one suffix is for liquid in pipe A, two suffix is for the liquid in pipe B, and G suffix is for the heavy liquid which is the mercury present in the UTube manometer here. Okay, so from the equilibrium condition we'll get the relationship like this for the two pressures acting, total pressures acting in left and right limb. So in this case we can write it as PA minus PB also. So try to write PA minus, when you take this PB from right to left, it becomes negative, then PA minus PB is equal to, we can write it as, first I would like to write ρ2 GH2 minus, we can write it as ρ1 GH1. When this ρ1 GH1 comes to right side, it becomes negative, then we can write it as ρ1 GH1, and the remaining term is related to heavy liquid plus, as it is write down, ρ G G Hg. Okay, so this is the relation by which we can find out the pressure in between the two pipes, and don't consider this is as a formula. So this is only the analysis we are applying to the differential UTube manometer for finding the pressure difference between the 2 points in two different pipes here. Okay, so this is the equation we can use, this is the analysis we can do, we can give to the differential UTube manometer for finding the pressure difference. Okay, and again when you keenly observe here the two pipes are at two different levels, but another case we can face when the two pipes are at the same level. So how can we analyze? So that means in the same way we can analyze. So next case we can consider when two pipes are at same level. So like this, when the two pipes are at same level at two different points, we need to find out the pressure difference. So arrangement we can give like this. Okay, so according to the arrangement, again the liquid from pipe A, liquid from pipe B tries to enter into the two limbs. Okay, and when it enters, so automatically according to the pressure difference, fall and rise of the heavy liquid in the UTube manometer, that is the UTube differential manometer, takes place. So according to this, again we can take a datum line. So with respect to the datum line, again the height of the liquid in the left limb we can assume as H1, and height of the liquid, that is from pipe B, in the right limb we can assume as H2, and the height of the heavy liquid in the right limb from the datum we can assume as Hg. So the same terms we have used. So when you analyze the same total pressure in the left limb and the total pressure in the right limb, the same formula we get whatever we got in the previous case, that is when the two pipes are at two different levels. But here we can simplify this equation in the form of, here when you keenly observe, Hg can be written as H1 minus H2. So in place of Hg, directly we can write it as H1 minus H2. So that means if in the problem, if only the height of the liquid which is in the right limb and the height of the heavy liquid is given, we can find out the H1 by summing up these two. If the height of the liquid in the left limb and the height of the liquid in the right limb are given, we can find out the Hg. So that means a small modification we can give. Here I am assuming the Hg. So Hg is equal to, we can write it as total height H1 minus H2, that is the height of the liquid in the right limb. Then automatically we get the Hg. So this is the modification we can give for the pipes when they are at same level, when the height of the two pipes is same. So the same formula we get, but we can do a simple modification that Hg is equal to, we can write it as difference of the two liquid levels in the two limbs. Okay, so this is the analysis we can give it to the differential UTube manometer. Okay, so I hope you understand, and the next video we will discuss about the next type of the differential UTube manometer, that is inverted differential UTube manometer, which is used for finding the low pressure values. Okay, so up to this I hope you understand. If you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And if you understood, try to solve one example problem by going through any kind of textbook, that is DS Kumar, author I am giving DS Kumar or RK Bansal or Modi and Seth. Okay, take the reference of these three, select any one and try to solve one example problem. Otherwise, in the next videos I'll give one example problem also, and wait and watch. So once again, thanks for watching my video. Thank you all. If you have still not subscribed to my channel, please subscribe and share my videos with your friends. Once again, thank you all.